What's poppin' YouTube? You know what time it is. It's Advent of Code Day 1, 2023. We're gonna check out the problem, walk through it. I honestly intended to be here right on time for the countdown, but finished up that sweet victory from the Dallas Cowboys versus the Seattle Seahawks, and well, let's just say I got busy. So let's dive right in. 2023, Day 1. Day 1, Trebuchet. Something is wrong with global snow production, and you've been selected to take a look. The elves have even given you a map. On it, they've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You try to ask why they can't just use a weather machine, not powerful enough, and whether they're even sending you the sky, and why your map looks mostly blank. You sure ask a lot of questions. And hang on, did they just say the sky? When you realize that the elves are already loading you into a trebuchet, please hold still. We need to strap you in. As they're making the final adjustments, they discover that their calibration document, your puzzle input, has been amended by a very young elf, who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the document. The newly improved calibration document consists of lines of text. Each line originally contains a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. For example, given this input, I'm not going to read all that. In this example, the calibration value of these 4 lines are 1, 2, 3, 8, 1, 5, 7, 7. Adding these together produces 1, 4, and 2. Considering your entire calibration document was the sum of all of the calibration values. All right, so 1 ABC, you are okay. So there's 1 integer, 1 integer, 1, 1, 1, 1, and there's some numbers in between. This is an interesting one. So the 7 is only in there once, but from the left, it is the only digit, and from the right, it is the only digit. So how do we solve? Well, there's 2 options to solve. One is we just simply take 2 separate indexes and we scan from left to right until we get some sort of int match, and then right to left, doing the same thing. And if the value is that, then we go with that. The other option we have is doing some sort of regex where we can do a pattern match on the first character from the left and then the last character from the right, or number, I should say, a /d. And in this edge case, where we only have 1 number or numeric found, the second one might not be populated. So we could try to capture both in a single regex, and then we just know that if we don't have the second one, which is optional, then the second becomes the first. We'll just go with the first. So, which is just, we'll create 2 indexes, we'll go from the left and the right, and we'll check each value to see if it is in fact an int. And if it is, then we'll go from there. And then I think we can do a sequence. I'm wondering if 0 is in here. That's just something else that kind of popped into mind. So this is our test input. So we'll go with this, and we'll just go ahead and create a test right out of the gate. So we've got our expected, which I don't know what that was. I'll just give it 0 for right now. And then our input is of that. Okay, we're just going to go with a new file. We're going to call it test. And we're going to rid of that. Okay. And we'll just simply put B here. Am I missing embedded? Is that the issue? Okay. All right. And then our expected input is 142. Okay. Got 0. Great. Let's forget if it's. There you go. Okay. So we're going to split that, and that's going to return slice of byte. And so we're going to say for that gives us each line, and then now all we have to do is loop through the bytes, or each byte. So we're going to just kind of iterate through each one. We're going to get the individual score, and we're going to pass the score back. So the score is just simply going to be 2 left, right, So what we're going to do is we're going to create yeah. So what we're doing is creating a byte array or byte slice of the characters that we want to search for, which is 0 through 9. And then we're using low, saying, hey, which is this library that has a couple of helper functions. Although I think some of this might be built into the standard library now. And we're just saying, hey, is that character contained within this slice? And if it is, then we know we've got it, and that's a left. And then we could do the low dot reverse and do the opposite. Now, the downside here, we're doing a lot of check operations, but I think we could probably look at the rune or the numerical representation of the character and see if it's within a certain range of value, which would probably be a little bit faster. But I'm just going to go with this for now. So what's the, is there a byte convert package? There's a string convert. Package, but I'm not. Let me see. Yeah. Okay. Well, I don't know the answer to this, so I'm going to go with the answer that I know, which is this, and we're going to go with left, and we'll go with all right. So there we go. So let's run our test. And it fails. Expected 142, actual 0. Put the data in the test file and run the test. All right. We've got, we'll get rid of that for now. 12 when our expected is 142. Okay, let's look at our input and see. So our 12, okay. So I see the problem. Okay, this needs to be right. And then run this. And we've got 34. Okay. Do another set here. And let's see. And let's look at our rules. So, okay. Dang it, I do this every time. I didn't read the rules correctly, so instead of it being the addition of the two numbers, which for some reason that was my assumption, it's the two strings concatenated together and then turn it into an int. So we will do this. I got an extra set of parens here. Okay, I didn't realize you could do that. All right, that should be it. Okay. Oh, these are runes. So the plus down at the bottom is doing math on them, and it's because they technically I think are ints, and so I just need to. Yeah. $21. Ah, okay. So once we have it, we need to break out. Okay, this should be it. Got it. Okay. So now the plan is we've got a 1.txt, and we will give it our input, and we will provide that here. Wow. 56,108. All right, cool. Moving on to part 2. Your calculation isn't quite right. Looks like some of the digits are actually spelled out with letters. 1, 2, 3, 4, 5, 6, 7, 8, and 9 also count as valid digits. Equipped with this new information, you now need to find the real first and last digit on each line. For example, in this example, the calibration values are 29, 823, which is 8313, okay, because there's the 1. Okay, well, that was quite a curveball. I didn't see that one coming. So how do we solve that? Okay, so there's a couple different ways. The first way that I can think about this is that really we can start with just the first character and continue to do what I'm doing. So an OTT or an OTF, S, E, and N. And only if those are present, they indicate a potential for those specific numbers. And then we can check to see if the next preceding characters match. And then in the backwards way, we would have to work backwards in the numerics. And because even though I'm doing the reversal of the string just for ease of traversal, you still have NEET. Like if you look at that last example with 16, we're going to start at N, check N, then E, then E, then T, then X, then I, then S, and then an S. It's going to be a SIX. So that's where they get the 76 from. So, now for simplicity, I could just always walk from the left to the right and always catalog the rightmost number instead of doing the reversal. It just means that I won't be bounding it, and it might make the logic easier. So, yeah. So what we could do, just to change like our base problem or base resolution, is if left equal, what's it, empty? Is that right? Would this be 0 maybe? Oof, okay. Left equals R. And then right always equals R. Right? Okay. And then we get rid of this. So what that means is that even on the first one, both left and right will get assigned. And then from that way forward, only right will be assigned. And then whatever right is at the end is what right is at the end. I think that kind of makes sense for this. So I'm going to start with that, change the implementation here, rerun my test still pass. I'm good to go there. And then this will allow me to just kind of work with everything forward thinking when it comes to the resolutions. So, okay, so that's done. The other thing I'm going to need is the index. And then I'm just going to get the length of S so I don't have to recalculate it over and over again, just to make things a little bit faster, although I don't think in this problem case it really matters. The reason why I'm getting I is because there might be some scenarios where if we go back to our like kind of test input, I want to start with just the letter, and if one of the letters is true, actually I might just do an if statement, then I know like, okay, I'm potentially, because the first character is an O, I need to check to see if the next preceding two characters is an N and an E. Same thing with TWO, 3, 4, 5, 6, 7, etc. So I think that's what I'm going to do. And then I'm going to just, for simplicity, I'm going to do continues here. So we can just say if R equals O, then we know we want to check for the word one. So in order for the word one to be true, we can do a couple different validators here. So if I plus 2 is greater than L minus 1. So what I'm doing is I'm saying like, make sure that we're not at the end of the index or end of the word. Then if it is, we'll just continue because we know there's really nothing to do there. And then if it's not, then we're going to say, okay, so if S sub I 3 equal to this is what I get for wanting to just work with bytes. Okay, let's work with bytes. Let's not queue up so equal. Bytes dot equal. Yeah, why didn't, jeez, Chris. All right. We can play this game. All right, so if they're not equal, we continue. Okay, so that's our other exit strategy. Otherwise, we follow this pattern. So if left equals 0, left equal to 1, right equal to 1, and continue. So that's kind of my structure for this. So if we rerun this, I don't think our test input has actual words, which doesn't. So we're going to go ahead and do a test2.txt. And in here, we're going to add our different input. I feel like Avenant Code's coming out swinging this time with this complexity, and then the different inputs, because it seems like last year they used a lot of the same inputs, at least from what I could tell. Okay, so that means that given test 2, let's scope it down to just the 1 and then a 4. So we should get 14 for test 2. So All right. 1424. Okay. So let's look at our test input. Right, so it went all the way to the 2. So what didn't work? My guess, I always mess this up. It's this representation here. For whatever reason. Okay. We'll dig in. I always do that wrong, and yeah. All right, so we've got our rules for 1. Okay. Let's look at our other number combinations, because 2, HTWO, 3, 4, 5, 6, 7, 8, and 9. Okay, we're on to something here. Okay. This is like incredibly ugly though. That's fine. Okay. We'll do like this. 1, 2, yeah. Let's not get crazy. We're gonna do it, and then that's plus 2, so that's 5, so that's 4. And then we're gonna come up with a better way. I mean, I could reduce this by creating a slice and some sort of indexing. It just feels so brute force right now. Oh man, I can't do the continues for the F's if I do it this way, because let's rethink this strategy. Strategy works simplistically. Okay, let's go back with let's okay. We'll go with I think this will be a little bit better. We'll go with let's just copy this out of here. Except I want this to be, so we're going with bytes, right, boys? And then we will just simply why am I going with bytes? Because I'm a masochist. Okay, I changed my mind. We'll go with string. Okay. Words. Let me fix these. So I guess 0 is not one of them. All right. So we're going to take a different approach. I started brute forcing this, and it was giving me a headache. So what we're going to do, probably, again, not supervision, but instead of checking, we're going to basically do this check, but we're going to infer all the data, and we're going to have to check each value. So for range of words, if R equals to the key sub 0, so that's the first letter, that's going to be our indicator to do some additional logic. Why am I doing that? I just feel like it'll help things be a little bit more efficient if we're only looking for a couple of letters. I guess I could do a more efficient kind of map, but you know, we'll just go ahead and go with byte. So that's pretty much straightforward. And then our value is going to be V, and our right is going to be V. And then the rest of this can be inferred. So we want to see if the length of the string -1 is less than I plus the length of K. -1. -1 because we're already at O. So we only need 2 more added. And then this becomes the length of K. This is K. And then the rest remains true. All right, so I'm not gonna be able to exit early, but all these continues. We can break here because we're gonna break out of this loop. It doesn't really do anything after, so we're fine. So if we assign a value, we know we found it, get out, and we're good to go. I feel much better about this solution. Haven't tested it, but I feel like it's right. So let's look at our test2.txt. We still have that one example in here. This is beauty of TDD here, guys. Beauty of TDD is the fact that I could change things so drastically from a initial approach and take a step back and go, you know what? We're being dumb. Let's try it a different way, implement a different way, and get an immediate response as to what my level of accuracy is. So we might, if I was really doing this, I would test each input individually and make sure that they kind of add up. And I have a feeling I might get bit here in a second. But we're not going to do that. We're just going to test the whole thing, and we're going to see if it if it gives us 281 like we want. Okay, beautiful. So really for our command, there's really no different, except the input is going to be different. So and we'll do 2.txt for the actual input, and we'll give it b2. There's really no part 2, so we're not going to worry about that. But I mean, we could have branched the function, but I'm not going to, or create a different one. Get puzzle input. Go back to our 2.txt. Let me just make sure I did this right. Wouldn't that be something if the values were exactly the same? Something feels broken there, but we're going to go with it. Well, that's it. All right. Well, let's kind of review the answer. So our approach, it changed slightly from the beginning, where we were being kind of lazy, to our end result. But we have this get score function that has two different searches. One is a straight numeric search, and the second is a word specific search that is a mapping from word to set integers. These are represented as byte, and we grab the initial length of the string, and then we iterate through that string or that byte slice, and we check to see, is this rune or character, so 0, 1, 2, 3, 4, whatever character we're on, is it in our search list? So that's our numbers 0 through 9. If it is, we're just checking to see if left is currently set. If it's 0, not set, then we set it to R. And then because we matched here, we always set right to R. And then we can continue this main loop because we found a numeric match. If it's not numeric, then we're going to loop through this map of strings to numerical representations, I guess. Although we could probably avoid the convert. It's fine. Everything's converted at the end. And so what we're simply doing is just saying, hey, loop through that set. If we look at the first character of each key, so that would be these characters right here. So O, T, T, F, F, S, S, E, E, and N. I could do some optimization where we're doing only one check for T and one check for F. Wouldn't it be hard to put that together, but not going to do that for this problem. And if the first character matches, if the character we're analyzing R matches anything in that for the first letter of any of those keys, then we do a simple length check. So the reason we're doing that is we want to make sure that we have enough left in our byte slice to compare this word to. If we don't, we continue and we move on to the next one. But if we do happen to be there, then we will then compare and grab out and take just that chunk of the slice from that character forward the length of K, which is the key, and compare it to K, which is the key. If those don't equal, we continue to the next one. But if they do, we go through that same operation of setting left and right. And we know, like, for instance, if we match on 2, well, that's not going to match 3. So we can go ahead and exit. We can break. Fortunate enough to only do 0 through 9 or 1 through 9. If we had like 22, well, this becomes a much more complicated problem. But this is a kind of an archaic approach that is fast enough. If I wanted to further optimize, I would go, instead of maybe ripping out the string, I would just go character by character forward against the key and loop until at the end. And at any point the character doesn't match, we continue. And that would probably be a little bit faster, but in this case, it doesn't matter. So that's exciting. I'm excited for Advent of Code 2023. That's day 1 in the books. If you have any questions, please feel free to comment below. And why don't you like and hit that subscribe button. All right, I'm out.